Hello everyone, my name is Karen Aranas and here's my final output for Man201, Regression Analysis of Medical Insurance Cost Affecting Factors. This study aims to understand the factors that affects medical insurance costs by setting the relevant indicators by linear regression model and analysis, also to predict the price of medical insurance. For the dataset, in this study, I have used the Kaggle dataset of medical insurance cost and trained model on attributes like age, sex, BMI, children, smoker, and region. You can see all the attributes in the following table. On the left side are the attributes and on the right side are the description. First here is age of the primary beneficiary. Sex, gender of the patient. BMI is the body mass index, providing an understanding of the body, weights that are relatively high or low relative to height, objective index of the body weight using the ratio of height to weight, ideally 18.5 to 24.9. Children, number of children covered by medical insurance. Smoker, region, the beneficiary residential area in the US, Northeast, Southeast, Southwest, and Northwest. Charges are the medical insurance price. For the data processing and data cleaning, I use Python programming. I first import the extracted data to load the dataset. So explanatory data analysis, also known as data exploration, is a step in data analysis process where a number of techniques are used to better understand the dataset being used. Understanding the variables and data cleaning. I first identify the head and the sample. Sorry, I first identify the head and the shape of the data. So in this data set, I have 1,338 samples and 7 columns. On the lower right side, I list down the types of all the columns on our datasets. So for each, that's integer, sex for object, BMI for float, children integer, smoker object, region object, charges are float. Also on the lower left side, I used null function to check for null values, which is 0. And for statistical summary, I used dfDescribe function to show the statistical summary, which gives me the mean, standard deviation, minimum, and maximum. For the data visualization, I used histogram, which are most common graphs used to display numerical data, and scatterplot, which are useful for many reasons like correlation matrices. It also allows us to quickly understand a relationship between two variables. Here is the data distribution. It gives us a normal distribution for charges. On the right side are the charges by region. So overall, the highest medical charges are in the southeast and the lowest are in the southwest, taking into account certain factors, sex, smoking, having children. Let's see how it changes by region. As we can see from the bar plots, the highest charges due to smoking are still in the southeast, but the lowest are in the northeast. People in the southwest generally smoke more than people in the northeast, but people in the northeast have higher charges by gender than in the southwest and northwest overall. And people with children tend to have higher medical cost overall as well. Now, let's analyze the medical charges by age, BMI, and children according to the smoking factor. Smoking has the highest impact on the medical cost, even though the costs are growing with age, BMI, and children. Also, people who have children generally smoke less. In this study, I also used the heat map to visualize the correlation. There is no correlation except with the smoking. I used 3 different regression analysis. First is linear regression, which gives me a regression score of 0.7998. Next is ridge regression, which gives me a regression score of 0.7996. And the third is the polynomial regression, which gives me the highest regression score, which is 0.8812. On this slide, I'm showing you the predicted and actual values. I also put in the feature importance ranking, which smoker comes first, which 0.601678. Second is the BMI. Third is age, four children. Fifth is region, and last is sex. Comparing the actual output values with the predicted values that shows on the right side, actual versus predicted. And for the result and analysis, polynomial regression analysis, which gives me the highest regression score, which is 0.8812. So, linear regression is the simplest supervised machine learning algorithm where the target output is continuous. Linear regression is created to predict values within a continuous range rather than trying to classify different classes. Behind the algorithm, it uses the traditional slope-intercept form, where m and b are the variables of our algorithm. It tries to predict the best fit line that describes the relationship between the input features and the target variable. As a conclusion, as shown from the previous slides, smoking is the greatest factors that affects medical cost charges. Then it's BMI and age. The main objective was to explain distinct regression strategies of data mining that may prove to be useful in predicting effective medical health insurance price and facilitates insurers and patients to obtain their goals. I aim turned into getting as high accuracy with decreased range of attribute as possible. In the future, we can practice more strategies to get even more accurate scores for medical insurance costs. Thank you.